morning, good evening, good afternoon, whatever time it is. Hopefully you're not up too late studying. If you're studying for the Algebra 1 exam, I'm trying to give you as many hints and as tips as possible to get through this. If you took the Algebra exam and you're finally waiting for us to get this out, man, New York State's crazy. They made us wait till June 30th to get this stuff out. I don't even know why. I hope us teachers can rally and fix that because I think that's a mistake. I think kids want to know immediately after they took their test how they did, at least within a couple of days. At any rate, my name is Mr. Krause. You can call me Mr. Key for a little while. My name's Mr. Key. We got this ugly black pen going from last time. Let's change that to red. Everybody loves red. This is going to be part 1. Problems 13 through 24. And remember, all of this stuff can be neatly found at www.nkinfinity. I just spelled infinity wrong. Infinity.com. Look it up. You'll be able to do it. All right, let's get it. Let's go right to 13. We got to get all this stuff we already did. All right, problem 13. Which value would be a solution for x in this inequality? So we're looking for something that's less than 7, not equal to 7. So one of these is going to be equal to 7. My guess, this one is the one that's going to be equal to 7. Right? If you plug in that, you get 47 minus 4 times 10. That's 40. So that 7 is less than, less than 7. They're trying to trick you there. That's not going to work, kids. Not going to work at all. So if you plug in 11, you get 47 minus 44. Well, 47 minus 44 is 3. 47 minus 44 is 3. So 3 is less than 7. There's the answer. With these negatives, don't forget, these negatives, when you plug in a negative here, you actually have a negative times a negative. So you're actually getting bigger because you're adding something. So don't fall for that one. 13 is 3. 13 is choice 4. Bella! No, that's Stella. Bella recorded data and used her graphing calculator to find the equation for the line of best fit. She then used the correlation coefficient to determine the strength of the linear fit. Which correlation coefficient represents the strongest linear relationship? Well, strongest doesn't mean positive or negative. Strongest means closest to either -1 or +1. So those are your two extremes. That's very strong. And this is very strong. So we're looking for a strong linear relationship. So 0.5 wouldn't be it. So is it -0.8 or is it 0.9? 0.9 is stronger, so that's the big winner. The lengths in inches of 12 students are listed below. Which statement best describes the spread of this data? Well, we're going to have to get this stuff typed in. So I'm going to bring it over here. I thought I was. Maybe I'll bring my calculator over there. So, where's my calculator? Calculator, go to my calculator. There it is. Oh, come on. Stop messing with me. All right, there it is. So, I'll go into spreadsheet mode. And I'll type in X. Sorry, I'm not moving very quickly. I hurt my back somehow. So I'm moving like an old man, which I kind of am. 61, 67. The best thing to do is type this stuff in. The best thing to do is type it in twice. Do it right. 62, 65, 59, 60, 79, 60, 61, 64, 63. Hopefully I got those in right. Did it say 12? 12. I got 12 students. So what I'm going to do is one variable statistics on this. So menu, statistics, stat calculations, one var stat. Click OK. Click OK. Oh, my poor doggy. Not sure why I didn't like that. Menu, statistics, stat calculations, one variable statistics. OK. Oh, X list. X. Oh, it's called X. Oh, yeah, duh. Okay. Okay. So what do we got here? We got an X bar. That's the mean is 64. So let's write this stuff down. We got a mean of 64. What's our median? Our median is 62.5. What else are they talking about here? The median is 59. So that's not right. The set of data is skewed because 59 is the only value below 60. Oh, well, I don't know if it's skewed until I look at it. So what I'm going to do is go Doc, Insert, Data and Statistics, and I'm going to click on X. I don't think that's going to... I guess it's a little skewed. It's a little bit skewed to the right here because of this. Does this write 79? And 79 is an outlier which could affect the standard deviation of this data. Huh. The set of data is evenly spread. Does that look evenly spread? Not really. What is this, 15? The set of data is skewed because 59 is the only value below 60. Oh, that's just stupid. I don't really like this. The 79 is an outlier which could affect the standard deviation of this data. It does look like 79 is in fact an outlier. I wonder if I can do menu, analyze, no, plot type. Let's go to plot type and let's do box plot. This will tell us if it's an outlier. You see how if we go to box plot, it usually will tell us that this is an outlier. By doing this little separation here, that will tell us that this is an outlier. So that would be, I guess, the answer. We'll go with that. In statistics, in AP statistics, and in Algebra 2, we have a little bit more of a algebraic way of determining that, but I'm not going to get into that with you right now. The graph of the quadratic function is shown below. An equation that represents this function could be, well, because it's coming down, it has to have a negative leading coefficient, so it can't be these two. It moved to the right 15 and up 25. So this vertex is 15, 25. And each of these answers are in vertex mode. Well, you need to remember for translation purposes, if I move to the right 15, I'm looking for a negative in here. Remember, this will tell us our left and right movement, but it's backwards, right? So this means we move to the left 15, and that's not what we did. We moved to the right 15. We also moved up 25, so this is the big winner right here. What number is this? I'm going to check these as I go along this time. 16 is 4. Good. All right. And I could graph that. Please, graph it on your graphing calculator and triple check. I don't care how doggone smart you are. Graph that thing on your graphing calculator and verify what's going on. I mean, it doesn't take very long. Check it out. Bam. Get rid of all this crap. Don't save it. Go into calculator mode. And I think that's the right answer, right? So I'm going to go negative 0.5. I don't like typing in halves. Parenthesis. X plus, minus 15. Parenthesis squared plus 25. I hit enter. I double click on this and I'm going to choose 30. And I'm going to double click on this over here. And I'll choose, I don't know, 30. All right, there we go. Now I just want to find out what that vertex is. So I can go menu, analyze the graph, maximum, click. There it is, 1525. And that verifies that I am in fact correct. And once you're correct, and once you know you're correct, man, all these ones that you know for sure, go back and go, nailed it. Don't have to look at that one again, right? Which statement is true about the quadratic function? We're going to talk about slope on here, aren't we? All right, so my vertex here, boy, this is another vertex question, is positive 3, positive 2. That's my vertex. They have, of this one. Oh, that's f of x. G of x here, my vertex is here, which is positive 3, negative 5. They have the same vertex? No. They have the same zeros? I don't know. They have the same axis of symmetry. That's true. This is the answer. And they have the same intersection points. They intersect at 2 points. I have no idea if they intersect at 2 points. I'm trying to figure out if there's a better way to do this one. The reason that they have the same axis of symmetry is because if you look at a parabola, the equation of the axis of symmetry is x equals, and it's always the x value of the vertex. And since both of them have a vertex of 3, 2, and this one has a vertex of 3, negative 5, they both have the same axis of symmetry, 17. But do they have the same zeros? This one has irrational zeros. I don't even know what its zeros are. I have no idea what that one's zeros are. Unless I could come up with that equation, I wouldn't know what its zeros are. It's somewhere between 5 and 6. Now, I could graph this one. Let's graph this one. Let's just see what I can get here. Let's go tab. What is it? Parenthesis, oops. Parenthesis x minus 3. Parenthesis squared plus 2. All right, so this one doesn't even have any x-intercepts. So do they have the same zeros? No, because they don't have any x-intercepts. Do they intersect at 2 points? Well, this is a parabola that's facing down. I do know that. Why do I know it's facing down? Because this is the highest point. Oh, wait. No, that's the lowest point. Yeah, that's the lowest point. So I wouldn't even know. I mean, the equation, yeah, the equation of this, I actually do know the equation of this. The equation of this is x plus 5, excuse me, x minus 3 squared plus 5. Minus 5. Doggone it. I'm having a hard time. So you just take the vertex. So I guess I could go tab. I guess I do know this one. And it's parenthesis, it's x minus 3 parentheses squared minus 5. Enter. Kind of looks like they never hit each other. Doesn't look like they're going to ever hit each other. So looks like they have no points of intersection. So anyway, they have the same axis of symmetry. Given the relation, let me stop for now and I'll come back to this one. All right, given the function defined by the following. F of 1 is 2. F of n is negative 5 times f of n minus 1 plus 2. Which of the following could represent the range of the function? Well, it has to have a 2 in it. This one has a 2 in it. This one has a 2 in it. So it can't be one of these two. So if I plugged in a 2, let's do f of 2. What that means is it's negative 5 times f of, let me do it this way because it probably looks better for you guys, times f of 2 minus 1 plus 2. Well, 2 minus 1 is really just a 1. So what is f of 1? F of 1 is 2. So negative 5 times 2 plus 2. What's negative 5? Times 2 is negative 10 plus 2 is negative 8. Negative 8. And then if I do this again, f of 3 would be equal to negative 5. Now this thing here, and I don't know how much you guys get into recursion, this thing right here just means the term before. That's what recursion means. It just means the term before. So the term before in this case is, what do we say, negative 8 plus 2. So that's 40 plus 2 is 42. So this would be the right answer right here. Choice 2. An equation given by that. Wow, what a mess. The solution to this equation is, well, I'm going to tell you right now, what I would just do is graph this. We're going to do this two ways. I'm going to do it algebraically, but I'm going to do it graphically because I think if you can graph something, you should be able to graph it. All right? If you can graph something, graph it, please. So we're going to graph the left side, which is 4 times x minus 7. 4 parenthesis x minus 7, enter. And then we're going to graph, we're going to tab 0.3 parenthesis x plus 2 parenthesis. I think that's it. Oh, plus 2.11. Plus 2.11. Don't forget that. All right, so there's your point of intersection right there. So all we got to do is find out what that point of intersection is. So we're going to go menu, analyze the graph, intersection, click, click. Now remember, we're looking for the x value. We don't care about the y value because notice we're trying to solve for x here. And the x value is 8.3. Although I bet they didn't even have 5.2 as an answer. They should. So, okay, now how do I solve it algebraically? Well, algebraically, you have to get rid of the parentheses. So it's 4x minus 28 is equal to 0.3x plus 0.6 plus 2.11. So this is 4x minus 28 is equal to 0.3x plus 2.71. We're going to subtract this 0.3. So I get 3.7x. I'm going to add this 28. This is a pain in the neck to do it this way. Add this 28. So I'm going to go to my calculator. 2.71 plus 28, 30.71. And I'm going to divide by 3.7. Divide by 3.7. 8.3. So that's the other way to do it. Kind of a pain, but not bad. Ooh, man, this looks like chemistry. A construction worker needs to move 120. What number am I on? 19. I just want to make sure 19 was 1. I didn't check it. Yes. A construction worker needs to move 120 cubic feet of dirt by using a wheelbarrow. One wheelbarrow loads 8 cubic feet of dirt. So let's start with that, because all we're going to do, I'm not even going to look over here. I'm not looking over there. I'm not looking. So 120 cubic feet. I know it looks like I'm looking, but I'm not. That's what we're going to start out with. Over 1. Let's just do this. Cubic feet. And we want to get rid of cubic feet, so we're going to do 8 cubic feet is 1 wheelbarrow. Oh, it takes them 10 minutes. It's 10 minutes. One correct way to figure out the number of hours he would need. So that's minutes. We got to get rid of minutes. So 60 minutes is 1 hour. Are we trying to figure out hours? One correct way to figure out the number of hours he would need to complete it. Hold on. 120 cubic feet of dirt by using a wheelbarrow. One wheelbarrow holds, and each load takes, All right, so this is really all I need. I don't even need that load stuff, but I need to get 8, so the cubic feet are gone. And minutes, see how minutes are on the same top and bottom? That means they don't go, so that can't be it. Do you see how we got cubic feet on top and cubic feet on top? That can't be it. We got cubic feet here on top and cubic feet here on top. That can't be it. So here we go. Cubic feet, cubic feet. Oops, I shouldn't get rid of the 8, just the cubic feet. Minutes and hours and 1 load and 1 load. Now that's what I was starting out with. I was starting out with 120 cubic feet. I actually snuck a peek at the answers. And then I said I was going to do 1 load, or 1 wheelbarrow is what I was going to do. 1 load is 8 feet, cubic feet. And then the cubic feet go. And then 1 load takes 10 minutes. So I do 10 minutes and 1 load. Sounds like I'm going to the bathroom. Sorry, that was disgusting, I know. And then to get rid of minutes, you got 60 minutes in 1 hour. So these are all the conversions that they do. I'm assuming that's the answer. That's choice 4. Choice 4. One characteristic of all linear functions is they change by equal factors over equal intervals. Unequal factors over equal intervals. That doesn't make any sense. Equal differences over equal intervals. Unequal, that's not it. Equal factors, equal differences. It would have to be equal differences, because think about this. Linear functions are, you're talking about the rate of change, and rate of change for a linear function is slope. And slope is defined by subtracting the y's over subtracting the x's. So you're looking for equal differences over equal differences, or equal intervals over equal differences, not this. It is kind of confusing, though, why you wouldn't choose 1, but I think factors are what we would consider not a linear function, but more of like a power function. All right, what are the solutions to this equation? Okay, I'm going to show you the right way to do this, and then I'm going to show you the cheating way of doing this. So we're going to do it the right way, and the right way is to do it by completing the square. So what we're going to do is we're going to say, okay, x squared minus 8x plus square is equal to 10 plus square. They already have it set up for completing the square. Remember, in here goes half of this, so minus 4, squared goes here, 16 and 16. So we get equals, on this side, 26. Take the square root of both sides. Don't forget to put a plus or minus. The square root of 26, and bring the 4 over. So it's positive 4 plus or minus the square root of 26. So I think that's the right answer. But what you need to do is make sure you are 100% correct. And we can do that very simply by doing it like this. We're going to do, why it does that all the time, 4 plus the square root of 26, and we're going to stow that, and you can do this on an 84 as well, into x. And then we're going to type in, don't type in the equal sign, just type in the left side, x squared minus 8x. And we're looking for 10. There it is. There it is, and there's your answer. And star it. Nailed it. All right, 23. The formula for blood flow rate is given by that, where that is that, where F is the flow rate, P1 is the initial pressure, P2 is the final pressure, and R is the resistance by blood vessel type. I wonder if this is actually true. Which formula cannot be derived from the given formula? Oh, man, you guys are jerks. All right, so let's solve for R. Looks like we got to solve for R. And we got to solve for P1, and we got to solve for P2. It's not as bad as you want. I know this looks really bad, but all we're going to do is cross multiply. So F times R is equal to, oops, a daisy doozy, P1 minus P2 times 1, which is just P1 minus P2. Well, if I wanted to solve for R, I would just divide by F. So R is equal to P1 minus P2 over F. So this says cannot be, right? So this one is can be. I'm pretty sure this is the answer. So let's do that same step now. But now we need to solve for P1. So if I want to solve for P1, I'm going to bring P2 over by adding P2. Adding P2. So I get F times R plus P2 is equal to P1. Now, I'm going to do the same thing, but now I'm going to solve for P2. Now, here's the problem. You notice how P2 is negative? Do you see this negative right here? See how it's negative? That's awful. That looks terrible. So it's negative, and I hate. When you get into Algebra 2, negatives will kick your butt over and over again. So what I'm actually going to do, I know this sounds counterintuitive, I'm going to move that over to that side. Because when I move that over to that side, I'm going to add P2. So P2 comes over here. So P2 plus FR is equal to P1. Now I'm going to move FR over. I'm going to subtract FR, and I'm going to subtract FR. And I get P1 minus FR is equal to P2, and that's this one. So that one's true. So there's your answer. Last one. Morgan throws a ball up in the air. Oh, Morgan, he's or she's so much fun with the ball up in the air. Oh, somebody needs breakfast. All right, now notice it's got a negative. It's negative. It's a parabola because it's x squared, so it's going to go up and then down. Where t represents the time in seconds since the ball was thrown. What is the appropriate domain for this situation? Now, domain is starting here at 0 and moving off to the right. So we want anything less than 0. Okay. Now, domain is only the x values, or in this case, the t values. This is the y values, or the range. So nothing with h of t makes any sense. And so I'm going to guess a ball in the air is only going to stay in about 1.5 seconds, probably not 9 seconds. But because I like to use my graphing calculator as a tool to assist me in my answers, I'm going to do that. So I'm going to type this thing in, negative 16x, not w, x squared plus 24x. All right, do you see how It starts here and ends at 1.5 seconds. Now, I'm guessing it probably goes 9 feet in the air. Yeah, but that's the height. That has nothing to do with the domain. So there's the answer, choice 1. All right, kids, we did it. We're done with the multiple choice. All right, I'll be right back with part 2s, 3s, and 4s.